Let's look at an overview of how to do a rapid prototyping method in Year 11 Systems Engineering. I'm going to use the example of creating an e-battery bike from 18 650 cells using a system of clips that have been developed on the top here that are commercially available but a bit hard to get at the moment, and they're also quite expensive for what they are. So looking at trying to create my own version of those clips, I first of all start modeling in CAD. I don't do too much drawing. I get a rough drawing by hand, but I start modeling in CAD and I start by drawing up what I think is going to work. I then create from that a drawing with some key features on it. For example, I've got there the diameter of the hole, the diameter of the smaller hole, some of the main heights and sizes. And I then annotate that for evaluation. So I print that out normally and write all over it what I think of certain bits. And I go through it and ask myself some key questions or develop a list of key questions out of that based on how it approaches or achieves my objective, which is to actually make a cell that works, clips together, that sort of thing. Once I've done that, I'll also do a render. The render often helps me to see things that I can't see in the diagram, and it gives me a good idea of how it's going to look in the future. So there you've got, I've got and rendered it with a cell in it. I've also put the screw thread in so you can see how the conductor is going to attach, and I put a red one on top and a black one on bottom for positive and negative. But you can see there that I've created a render, and the render is often helpful as well. As part of annotating this for evaluation, it might be a good idea to show this to a third party, another person, and get their impression of what they think of this particular idea. If you're designing this for a client, you would definitely send your render and your diagram or your drawing to the client and get them to give some feedback. But basically, I'm looking at this just from an aesthetic point of view and making sure it looks like it's going to work from a functional point of view. Now, at the moment, we can't fabricate it because we're in off-site learning, but I did fabricate this one. And there's the screw thread in. The screw's a bit longer than I anticipated because I don't have any short screws at the moment. But I had the screw thread in, and I did actually do a test evaluation. I plugged it into a battery. I had two of them. And the first evaluation was that it was too loose. And the second one was that those clips don't actually hold together very well at all. So I actually, from that, came up with a secondary sort of solution. Step 3 is to come up with a list of things to improve and do. Sorry, step 4 is to come up with a list of things to do or improve. So from that, I created a process journal with a list of tasks, experiments, or improvements that are required. So for example, in my list of things I needed to do, which was just a handwritten list, you need to create more of a process journal, was to actually make it loose. You can see the one on the left is quite loose. You can actually see a gap in there. Whereas the new one that I did was on the right. I decided to make my prototype very, very simple so it wouldn't take nearly as long to print. And that actually created in me a solution that I'll go forward with. But basically I've created this list of things to do and to work through in order to improve it. What you're going to need for your project check-in by the end of this week is to create your improvements from the feedback I gave you from the last project check-in, and then to add in an additional section called prototyping, and it should include prototyping of at least one system or one subsystem. And that should include an overview of the subsystem, at least one drawing of at least one subsystem, at least one render of at least one subsystem, and they should all be annotated, and at least one process journal in a state that's ready to use so that you can reapply that process again and get a better product